Okay, so we had arithmetic sequences on Friday. Today we're going to look at arithmetic series, and then we're going to also look at geometric sequences. And this is actually really interesting. You guys are going to like this. Second hour, like the example as well. Arithmetic series. What a series means is really a sum. So you can replace really this series with the word sum. And so when it says evaluate the related series of each sequence, you can tell that this is an arithmetic sequence. How do you know that this is an arithmetic sequence right here? Because you have a difference of 2 each time. And on Friday, we learned how to write a rule for that. And you remember that we had a sub n is equal to a sub 1, which is our first term, plus n minus 1 times d being the difference between the two terms. And so we could write a series for it, yada, yada, yada. But when it says evaluate the related series, all it means is that we add them up. We take 13 plus 15 plus 17 plus 19 plus 21 plus 23. We get the answer. That's easy to do, right? So let's move on to something more difficult, okay? Oh, you need a worksheet? Well, if you want, otherwise I'll just give you a new one. You do whatever you want to. I'll keep teaching. I think you would be of great value to watch this and just have me give you another one. I think that's what you should do. Here you go. Do-si-do. So let me show you an example, and I think you guys will really appreciate this. Story goes that there was a mathematician who at a younger age, say around 4th grade or 3rd grade or something like that, was kind of naughty during class and was supposed to stay after school until he had added up the numbers 1 through 100. And so the teacher left him by himself for a few minutes as she went to speak to somebody else and came back, and he had already added them up. He had come up to 5,050 in a matter of a minute, and he was gone. He left the answer on the board. Now, she was very confused at how he did that because she figured that he would go 1 plus 2, which is 3, plus 3, which is 6, plus 4, which is 10, plus 5. And boy, that would take a long time, wouldn't it? Well, here's his approach, and I think that this gives a really good idea for how we do arithmetic sequences, is he wrote it out like this. 1 plus 2 plus 3 plus 4 plus dot, 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 plus 97 plus 98 plus 99. Nope. Dot, dot, dot. Anybody see why this helps so much? Oh. Let's put our brains together. What does that mean? What does that mean? Oh, yeah. What does that mean? How many times? Oh, 50 pairs. Piece of cake upside down. Yeah. I don't remember. I got to look up the story. It's in a math book, history book. Oh, it is. It is. Yeah, it was. He was very young at that time, yeah. Saw numbers, saw patterns, liked it, said I can figure this out. So that's good stuff. So let's figure this out. Let's figure this out. Where did the number 101 come from? You took the sum of the first n terms is equal to. Where did the number 101 come from? How did we get that? We took the first term and we added it to the last term, right? Now, let's look at this. So that's where 101 came from. Where did 50 come from? Isn't 50 100 divided by 2? So 100 is the n, that's the number of terms, divided by 2. So here's what we learned. As we go to our sheet, you learn that evaluate each arithmetic series described. the sum of n terms in an arithmetic series is equal to the number of terms times the first term plus the last term divided by 2. And so we have our formula. And now you see what is set before you as a sigma. This is the Greek capital letter for S. There's also a Greek letter for sigma that looks like that. If the letter S comes in the middle of the word, it looks like that. If S comes at the end, then it looks like that. If it's a capital letter, then it looks like that. Okay, so those are all sigmas. And it means sum. It means sum. So this actually means the sum of all the terms generated by 5k minus 2, starting with k equals 1, all the way up to k equals 35. So we'll just shorthand write this right now. Does anybody know what the first term of that series would be? You just plug in 1. 5 times 1 is 5, minus 2 is 3. So 3 plus, let's plug in 2. 5 times 2 is 10, minus 2 is 8. Plus, let's plug in 3. 5 times 3 is 15, minus 2 is 13. Plus, dot, 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 plus all the way up to the very last term, right? And the very last term would be what we get when we plug in what? 35. 5 times 35 is 175. Minus 2 is 173. So, the question is, what do all those sum to? Well, that would take us a while to sit down and do it. We don't really actually have to sit down and manually figure it out, write them all out, add them up one by one. We can simply use our formula. And our formula says that the sum of the first 35 terms is equal to n. What is n in this case? 35, that's the number of terms, times, what's a sub 1? 3, plus, what's a sub n, the last term? 173, divided by 2. What do you get? 3080? Very good. You're super smart. What? Oh, it's a k equals 1. So it starts with 1 and it goes to 35. So this is where it starts and this is where it ends. Anissa, why don't you guys try a few more? Try a few more. I'll come around and answer some questions. Okay? Yep. All right, let's, you guys had some time to work. Let's move on to number 11. Really isn't much more difficult, you guys. Okay? Number 11, again, it wants the sum, and S sub n is equal to n times a sub 1 plus a sub n all over 2. So you're trying to find the sum of 14 terms. Do you know what n is? 14. Do you know what a sub 1 is? 42. Do you know what a sub 14 is? 146. So, they give you those pieces. It's just not written in sigma notation. Yeah. Come up with an answer. What do you get? What? Flip it over. Let's try something more difficult. How about we do? How about number 15? 15 says 20 plus 27 plus 34 plus 41, for n is equal to 16. So you want to try to find the sum of the first 16 terms. Okay, so I set it up. S sub 16 is equal to, what is n? 16 times, what's your first term? 20 plus, what's your last term? We don't know. It's the 16th term of this sequence, so I'm just going to put a parenthesis there. We got to figure that out. Divided by 2. Well, if I had a recursive, or if I had a formula, like we worked with on Friday, if I had a formula for an explicit formula for arithmetic sequence, I could figure out the 14th one, or the 16th one, couldn't I? And so we learned on Friday that a sub n is equal to a sub 1 plus n minus 1 times the difference. So using that formula, we can write an explicit formula so that we could simply plug in 16 and get something. So watch. A sub 16 is equal to, what is a sub 1? 20. Plus, what is n? 16 minus 1 is 15 times the difference. What's the difference each time? 7. So it looks like the a sub 16 term is 7 times 15. The difference between each term is 7. 7 times 15 is 105 plus 20. So now we can figure it out right. That's all there is to it. What'd you get? So 16, 17, 18, those fall like it. Let's try, I'll give you guys some time to work here. But first, let's look at one that's just a little bit more challenging. You can cross off 25 and 26. But let's look at problem 19 and problem 23, and then you guys can do some work there. Now it says determine the number of terms n in each arithmetic sequence, or series. And they tell you that S sub n is equal to 690. So I could set this up. 690 is equal to, do you know what n is? No. N times, what's the first term? 19 plus, what's the last term? 96 divided by 2. So can you solve for n now? Yeah. What do you get? Anybody got one? 12. So just take 19 plus 96 divided by 2, and then divide 690 by that, and you'll get it. Well, I said take 19 plus 96, divide that by 2, and then take the 690, divide by your new number. Or yes, you can multiply by 2. Either way, it'll come out the same. Any questions on that? Okay, then let's do 23. Can somebody tell me the constraints for 23? We were told what? That a sub 1 is equal to -3, that the difference is what? 2? And do they give us the sum? And you want to find the number of terms. Well, realize that we really have two formulas that we're able to work with. S sub n is equal to n times a sub n. I'm sorry, a sub 1. Whoop, I'm losing it now. A sub 1 plus a sub n divided by 2. And I know that a sub n is equal to a sub 1 plus n minus 1 times your difference. Okay, so I want to be able to find n being the number of terms. So I'm going to turn to my sum formula, and it says that S sub n is equal to 21. So I plug that in. Do we know what n is? No, we're trying to solve for it. So n times, do I know my first term? -3, do I know my last term? Nope. Divided by 2. Well, I have to know the last term. And realize that the last term is written as a sub n. Well, look at this. I have a formula for a sub n right there. And the formula for a sub n says that I take the first term, which is negative 3, plus n minus 1 times the difference. And the difference is 2. So if I work that through, I get negative 3 plus 2n minus 2, or 2n minus 5. So it looks like I don't actually have a number, but I have an expression for a sub n. So I could take that a sub n and replace it with 2n minus 5. Now maybe I could solve that. 21 is equal to n times, what's negative 3 and negative 5? So 2n minus 8 divided by 2. You guys help me out. This is algebra. What you want to do is solve. Okay, we could do that. 42 is equal to n times 2n minus 8. Now what? What? Nope. Multiply the n through 42 is equal to 2n squared minus 8n. Second degree equation. You got two methods for solving second degree equations. We have to set it equal to 0. That's number 1. And then we will either factor or use the quadratic formula. So I have 2n squared minus 8n minus 42. Now what? Take out a 2. Two numbers and multiply it to negative 21 to add a negative 4. Negative 7, positive 3, so my answers are 7 and negative 3. So you tell me. The question is, how many terms are there? Are there negative 7 terms? Are there negative 3 terms? Or are there both 7 and negative 3 terms? There are 7 terms. We cannot add up negative 3 terms. All right? Think about it. Now let's just put it in terms of people. If I wanted to add up 7 people's test scores in this classroom, could I do it? Yes. If I wanted to add up negative 3 people's test scores in this classroom, could I? No. There's nothing to add up. So 7 is the correct answer. So anyway, that should help you work through. Why don't you spend... I would like you to work through this portion right now. Start to finish up some of these problems. I'd like to start just the basics of geometric sequences. Actually, you know what? No, we'll do geometric sequences in series tomorrow. We'll spend all that time in tomorrow. Yep. So tomorrow will be the last of the stuff that we learn. You're going to have time to work and get a study guide on Wednesday. Preparation for the test on Thursday. If you want to take the test on Thursday, you can. And on Friday is test day. For everybody else, for those people who are gone at the Big 9, you would either take it next week or you would take it this week on Thursday. So it's up to you. So there we go. So finish up everything you can on that sheet. You should be good to go.